The chart below shows the names of the place values on both sides of the decimal point. To the left of the decimal point, the name of each place value is the same as with the whole numbers. So ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, and so on. To the right of the decimal point, the name of each place value corresponds to the denominator that is created by changing the decimal number in that column into a fraction. So tenths, hundredths, thousandths, 10,000s, 100,000s, millions, and again, so on. As an example, the 3 in the tenths column, so we would say there are 3 tenths, and would write 0.3 or 3 over 10. The 7 is in the hundredths column, and so we would say there are 7 hundredths, and write it as 0.07 or 7 over 100, and so on. Just kind of a note that we can write a whole number in decimal notation by placing a decimal point to its right and then adding one or more zeros to the right of the decimal point. So 99 is equal to 99.0 or 99.00, 99.0000. The extra zeros do not affect the number. Writing additional zeros to the right of a decimal point following the last non-zero digit does not change the value of the decimal. Deleting additional zeros to the right of the decimal point following the last non-zero digit also does not change the value of the decimal point either. So 12.37 is the same thing as 12.370, same thing as 12.3700. It does affect how you read the number technically, but the value of the number doesn't change. So in order, this is 12 and 37 hundredths, then it's 12 and 370 thousandths, then it's 12 and 3,700 over 10,000. Sometimes it is convenient to use rounding on decimal numbers, such as when you're adding up the cost of items in a grocery store to make sure you don't exceed your budget. When rounding a decimal number to a certain place value on the left side of the decimal point, all digits to the right of the place value become zeros until reaching the decimal point. At that point, all digits to the right of the decimal point should be removed. In other words, any decimal number that is rounded at a place value to the left of the decimal point should be written as a whole number. So to the nearest 10, 88 and 62 thousandths becomes 90. When rounding a decimal number to a certain place value on the right side of the decimal point, all digits to the right of that place value should be removed. So to the nearest tenth, 88 and 62 thousandths becomes 88 and 1/10. So to round a decimal to a specified decimal place, you locate the digit that is in that place that you're trying to round. That is the rounding digit. Then look at the test digit to the right of that rounding digit. If the test digit is 5 or greater, then you round up by adding 1 to the rounding digit and dropping all digits to the right. If the test digit is less than 5, then you round down by keeping the rounding digit and dropping all the digits to the right. So, for example, 645 and 13 hundredths to the nearest tenth, my rounding digit is the 1, and so I look at the 3 to the right of it. That's less than 5, so I would round down. 645 and 1/10. 33 and 97 thousandths to the nearest hundredth, I would round. This 9 here is my rounding digit, and the test digit is the 7. Since that's more than 5, I'm going to round up. And this becomes 33 and 10 hundredths. So it was 33 and 9 hundredths, round up to 33 and 10 hundredths. 708 and 522 thousandths to the nearest tenth. The tenth is the 5, and 2 comes after it, so round down. 708 and 5/10. 9 and 1,128 10,000ths. To the nearest thousandth, would be the 2 is in the thousandths place, and 8 is my test digit. I would round up. So 9 and 113 thousandths. All right, so let's determine whether each statement is true or false. So 0.9 is equal to 0.90. Yes, having the extra zeros at the end of the decimal doesn't change the number. So this is true. 1 and 260 thousandths compared to 1 and 206 thousandths. That is not true. The 6, in this case, the 6 on the left is in the hundredths place. On the number to the right, the 6 is in the thousandths place. So 600ths and 6 thousandths are not the same thing. 1 in 2,810 thousandths compared to 1 in 280 thousandths. Again, the extra zeros or removing zeros at the end of a decimal doesn't change anything. So this is true. Likewise, the number on the left is read as 1,000th. The number on the right is read as 1,000th. This is the same. That 0 at the very beginning is optional. It doesn't affect the value.